Hello everyone, today we're going to be talking about what a radian is, and in order to figure out what a radian is, we're actually going to do an M&M lab experiment. So we're going to just follow step-by-step processes for an M&M lab experiment to discover what is a radian. So the first step in my lab is to start with some sort of measurement, and I'm going to use my pencil as a straight edge. So I just need to make a measurement that's this much. And then we're going to bring our M&Ms into it. So I have to count from one edge to the other how many M&Ms are going to be the width of this potential radius of a circle. So I started drawing a radius of a circle. And so if I make a little tick mark at the end of my M&Ms, we should be able to connect it. Oh, that was pretty close. So my radius is 4 M&Ms long. Okay. The next thing I'm going to do is I'm going to take a compass. I'm going to measure the distance at which, this is an old compass. So I'm going to measure the distance at how wide my radius is, and then I'm going to draw a circle using this, and I'm pushing my M&Ms around. I'm sorry about that, and it's not 100% perfect, but hopefully that'll be good enough. My thing moved a little bit towards the end. Okay, so now what I'm going to do is, now that I know that my radius is 4 M&Ms long, I'm going to put 4 M&Ms along my circle, or my circumference of my circle, and every time I reach 4 M&Ms or the length of my radius, I'm going to make a tick mark. And then I'm just going to slide them from that tick mark and keep going. Oops. So I had 1 tick mark. Here's 2 tick marks, and then I'm going to keep going and sliding. Just sliding along. And it doesn't have to be 100% perfect, but I'm trying my best. Here's another tick mark. I'm lining up the edges, and I'm trying to get the middles to go from corner to corner of my tick mark to my next tick mark. Okay, there's another tick mark, and there's another tick mark. And we're going to go until the whole entire circle is completely done. And here's another tick mark, and it looks like I'm not even going to be able, so this is extra. So using my straight edge or my pencil, I'm going to connect the tick mark to the center of the circle. Okay. So I have 1, 2, 3, 4, 5, 6, and a little extra. So I have 1, 2, 3, 4, 5, 6, and a little extra sliver of how many pieces fit in this circle. So the definition of a radian, let me just explain this to you. The word radian sounds a lot like the word radius of a circle. So how are these two connected? So a radian is the measure of a central angle. So if this is a central angle in a circle, from the center that intercepts an arc, or a round part of a circle, whose length is the same as the radius. So if my radius was 4 M&Ms long, this was 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and a little bit extra. But we don't know how much that extra is. So we know it's 6 and a little. So one full circle with a radius of 4 M&Ms, we got 6 and a little radians for one circle. So the question is, what happens if we have a different size radius? What if we change that to be smaller or larger? So let's try again. So we're going to get a new sheet of paper, and we're going to make a radius that's smaller than that one. So we're going to make a radius That's even smaller. Let's see how many M&Ms that takes up. 1, 2, and I'm actually going to make a tick mark, and then I'm going to erase any of the excess. And then I'm going to take my compass. I'm going to measure just like we did last time. And then I'm going to have to make a circle by spinning it around. Okay, there's my circle. I have a radius of 2 M&Ms. So now I'm going to take 2 around and I'm going to make tick marks. So starting on the edge, we're going to see if our theory holds up where we have 6 and a little radians. So 1, 2, because my radius was 2. I'm going to do 2 more. And then shift these 2 down so I can measure some more. Here's 2. And then we're going to connect to the center of the circle. So there's 1. There's 2. 3. 4. 5, and what do you know? 6 and not even a full M&M of a little. So if we put them side by side to each other, we have one with 4 millimeters of a radius, or M&Ms of a radius, and 2 M&Ms of a radius. And when we still do this activity where we find how many radians, because radians are like how many radius of distance around a circle. Radius is like the straight edge of it, and a radian would be the curved arc of it. So it was 6 and a little. So where does that 6 and a little come from? So where does that 6 and a little come from? So have you ever heard of the number pi? Well, pi is 3.14159 yada 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 yada. And we know that pi also deals with circles. So if we know that pi is that, and we know that there's 360 degrees in a circle, then it must be the case that there are 2 pi radians in a full circle. So if I pull this a little closer for you, these are your notes. It says what is a radian. So here's the radius, or 1 radian. That's a whole arc length equal to a curved distance. So remember, a radian is an alternate way to measure angles, and it's the measure of a central angle of a circle that intercepts an arc whose length is the same as the radius of a circle. So if we approximated pi, we know that there are 2 pi radians, because if we took 2 times pi, we would get 6 and a little, which was all of our examples that we did with the M&Ms, in a full circle. Just like there's 360 degrees in a full circle. So now we have 2 example problems. So in order to convert back and forth between degrees and radians, we have to use this ratio. So the first example is converting this degree measure to radians. So whenever you want to solve for something, if you know that 360 degrees is going to be equal to 2 pi radians, then we can set up a ratio, or a proportion, a fraction set equal to a fraction, and then solve. So this would be 225 over 360 is going to be equal to what we want to find, which is the radians over 2 pi. So then we have to cross multiply. So 225 times 2 would be 450, keep pi as pi, and then 360 times x stays as 360x. And then you have to divide to get x alone, so divide, that's 360. 450 pi divided by 360. Those cancel, we get 45 divided by 36, which can be reduced if you take out a, what is 45 divided by 36 reduced? We can take out a 9 from both, which would reduce down to 5 pi over 4 radians. So 225 degrees is equal to 5 pi radians. Let's look at another example where we're converting from radians to degrees. So if I have 7 pi over 4 radians and I want to convert that to degrees, that's going to all be over 2 pi, which is going to be equal to x over 360. So if I want to cross multiply, I have to cross multiply this, which is going to turn to 2 pi x, keep pi as pi, remember, oops. And then if I'm going to be taking 7 pi divided by 4 times 360, remember a whole number can be written as a fraction over 1. So that means that I would just multiply the top times the top over the bottom times the bottom. And 360 times 7 is 2,520. Again, leave pi as pi, all divided by 4, and that's still going to be equal to my 2 pi times x. So now I can reduce 2,520 divided by 4 to simply 630. Keep pi as pi. We still have 2 pi times x. We want to isolate this variable x, so in order to undo multiplication, we're going to divide by 2 pi on both sides. Divide by 2 pi. That cancels. We get left with x is equal to, now we can take 630 divided by 2, which will get you 315. And then the pi's cancel because pi divided by pi is 1. So that becomes 315 degrees. So to sum up, in order to convert between degrees and radians, you can set up a proportion, which is a ratio equal to a ratio, and whatever number they give you, so like in this example, they gave me 225 as a degree, so that goes over the total, which is 360, and then I just put x, or a variable, to solve for over 2 pi radians. And then if they gave you the radians, we had to put that over 2 pi, and then that would be equal to x over 360 to solve for the degrees. So that is how radians happen to exist, and that is how you convert between radians and degrees. So remember that a radian is an alternate way to measure angles, and we talked about how it's the measure of a central angle of a circle that intercepts an arc whose length is the same as the radius of the circle. So that is what a radian is. So make sure you get these notes posted into your notebook and make sure you get these examples written down. And that is all that I have for you today. Good job.